So this is graphing equation, or writing equations of parallel and perpendicular lines. Okay, if we have the directions written, write the slope-intercept form of an equation of a line that passes through the given point and is parallel to the graph of the equation. Okay, so one of the most important parts here is it said that it's parallel to the graph. Okay, if the lines are parallel lines, we must know that parallel lines, the slopes are going to be the same. So let's write that. Parallel lines, and you can write same slope. So if my slope is 5 for one equation, this parallel line will have another slope of 5. If the slope is -3, then the other slope will also be -3. Parallel lines have the same slope. So I want to write an equation of a line that passes through this point here with the same slope of this equation. Well, we always need two things to write an equation. We need a slope and we need a point. Well, I have my point. My point is 3, 2, or my coordinate. But do I have a slope? It doesn't give me a slope. But what it does tell me is that my slope is parallel to this equation. So the question becomes, what is the slope to this equation here? What is the slope to this equation? Now, if you think about the slope-intercept form, y equals mx plus b, which one of these terms represents my slope? Which one of these variables represent my slope? M. Very good. So the question becomes, is what is my m in this equation? What is the m in y equals x plus 5?
3.
What is the m in y equals x plus 5? What is the m, the number or the coefficient in front of your x that represents your slope? In this case would be 1. There's nothing there, so we have to assume the m is 1. So my slope is 1 because my line, my noose line, is going to have a slope that's parallel to this equation. So if I'm parallel to this equation, I'm going to use the same slope as that equation. So now I have the point 3, 2, and I have the slope m equals 1. Now we want to write the equation on the line. Let's use point slope in this case. Let's use our point slope form to find the equation. So what is the point slope form of an equation? Yes. Y minus
y minus y1.
y sub 1 equals
Y sub 1 equals m times the quantity of x minus x sub 1.
excellent. So y minus y sub 1 equals m times the quantity x minus x sub 1. All right. In this case, I'm going to plug in for y1, x1, and my slope m. I have my y1, I have my x1, y1, and I have my slope. So let's go ahead and plug in so far. So we have y minus y1 in this case is going to be 2 equals m, which is 1, times the quantity x minus x1, which is 3. So again, all I plugged in was my x1, my y1, and my slope 1, and for these 2 points. I want to put this in slope-intercept form. I have a 1 in front of my parentheses here, so it's a positive 1. I can distribute a positive 1, but it's not going to change anything, so I can just drop this. So this is y minus 2 equals x minus 3. Am I in slope-intercept form yet? Am I in slope-intercept form yet? What do I have to do to put this into slope-intercept form? Okay, I want this to be y equals mx plus b. So only y should be on one side. What should I do? Very good. I'm going to bring my 2 over to the other side, so plus 2 both sides. This will isolate my y, which will give me just the left side equation where it says y equals x, and then -3 plus 2. I should get an answer of -1. So my slope here is, or my equation of this line is y equals -1. So same directions, write an equation of a line parallel to the graph going through the point -2, 5. So again, I need two things. I need a point and a slope. Question is, what is my slope and what is my point? Well, the point we already have, -2, 5. What is the slope I'm going to use? I want to write an equation that is parallel to this graph or to this equation. So from parallel to this equation, what am I going to take, or what information do I need from that equation that's going to help me write my new equation of my line? Okay, I'm going to take the slope from here, and what is the slope of that equation? Very good. The slope of this equation is -4. So again, mimicking y equals mx plus b, where m is my slope So my slope here is negative 4. So now let's write the equation of a line. And again, do I have a y-intercept here? Is negative 2, 5 a y-intercept? No, you're shaking your head. No. Why is it not a y-intercept? What must be true for this to be a y-intercept? Excellent. The x value would have to be 0. If this was 0, 5, then this would be a y-intercept, and I could just use my slope-intercept form. But I don't have that. So let's use my point-slope form again. So y minus y1 equals m times the quantity x minus x1. And again, I'm going to write this form as often as I can to help me plug in. I'm going to plug in my x1, y1, and my m. So y minus 5 equals m, which is in this case negative 4, times the quantity x minus, be careful here because this is a negative 2. Okay, so the minus sign to the formula and the minus sign to the coordinate are two separate minus signs. When I have them together, then I can put them together and say, okay, this is the same thing as saying y equal negative 4 times the quantity x plus 2. What should I do here? What's my next step? I want to put this in slope-intercept form. What can I do now? Very good. Let's distribute. So I got y minus 5 equals negative 4 times x, negative 4x, negative 4 times positive 2, negative 8. Very good. Is this in slope-intercept form yet? Okay. No. Why not? What do I have to do to get this in slope-intercept form? I want to isolate the y, get y by itself. So how do I get y by itself here? Good, I'm going to add 5 to both sides. So I got y equals, my 5 simplify or cancel there, negative 4x, and negative 8 plus 5, and I should get an answer of negative 3. So y equals negative 4x minus 3. If you notice the two equations, the first equation I had was y equals negative 4x plus 2, and the second equation I have is y equals negative 4x minus 3. So the only thing that's changing here is the y-intercept, or what points the equation is going through. But they will share the same slope. So same type of directions, except one slight difference. So write the slope-intercept form of an equation of a line that passes through the given point that is perpendicular to the graph. That is perpendicular to the graph of this equation. So again, I need a slope and a point to write my equation. I'm going to use this equation again to help me find my slope. What is the slope of this equation right now, as is right now? What is the slope of this equation?
Negative 1/3.
Okay, so the slope of this equation right now is negative 1/3. Me personally, when I did, okay, so now I want the perpendicular slope. So I would actually write m, and then I would write the perpendicular sign here. So this is the notation for perpendicular. So what is the perpendicular slope of this equation? What is the perpendicular slope of this equation? So right now it's negative 1/3. The perpendicular slope would be close. Positive 3 over 1. So again, your negative sign, or your sign changes to the opposite. So if the slope is negative, then the perpendicular slope would be positive, and then you're taking the reciprocal of whatever number you have. So you're taking the negative reciprocal to find the perpendicular slope. So the slope here is negative 1/3. Right away, my negative turns into a positive. My 1 over 3 now turns into the reciprocal of 3 over 1, or in this case, I could just say 3. So now I have my slope is 3. My point was negative 2, 2. I do not have a y-intercept again, so I'm going to use my point-slope form. So I'm going to go y minus y1, y sub 1 equals m times the quantity x minus x sub 1. Using my slope-intercept form. Plug in, y minus, my y1 is 2, equals 3 times x minus, be careful, it's negative 2, so minus 2 again. The two negatives here now become and make a positive. So I have y minus 2 equals 3 times the quantity x plus 2. Transfer this into slope-intercept form. I'm going to distribute first. So I got y minus 2 equals 3 times x, 3x, plus 3 times 2, 6. One last step here. Going to add 2 to both sides. And I got y equals 3x plus 8. And this is the equation of a line that is perpendicular to this graph passing through the point negative 2,